Sequence series review. A lot of this I'm going to use Desmos to figure this out. I could do this by hand, but if you can type in the symbol in Desmos and do n cubed minus 20, you will be just fine. So right here, this is summation. Um, I'm going to plug this in, but really what it's doing is it's saying, hey, if you put in 1 in here, you'd have 1 cubed minus 20 plus, if you put in n equals 2, you'd have 2 cubed minus 20. And then the last one they want you to put in is when n equals 3, which would be 3 cubed minus 20. Now, if you add all those up, you'll get the answer. So it's like this one plus this one plus this one. But the calculator will do it for you. I believe the answer is negative 24, but I want to use Desmos to show you. So here I go in Desmos. I'm going to close all these up here real quick. We got a lot of biz here. Okay. So I go to functions, and there's a bunch of stuff in here, and I'm looking for that weird e, which is the summation, and n equals 1, and on top is 3. Now I'm just going to bump over, and I use the parentheses because a lot of times if you don't, it'll screw it up. So the equation was n raised to the third power, and then bump over minus 20, and you get negative 24. So it does the answer for you. And then you get it and you can do that. Now I'm gonna do the same thing, but do it with this one and just get the answer. So I'm gonna just go back to Desmos, and this one was from 1 to 5. Oops, so I'm gonna change that to a 5. And then this was n cubed plus plus 3. And it pumps out the answer is 240. So that's a lot faster than doing it all by hand. But you can look on the answer key if you get that. All right, example of an arithmetic sequence. You get a lot of different ones, but you need to just remember this means adding by the same number, or you could think of adding a negative or subtracting. So I'll give an example of one where I subtract, but I can do 99, 98, 97, 96. So it's adding negative 1. You can go the other way and count up, but that would be arithmetic. Geometric is multiplying. A lot of people like to say dividing sometimes, but really we say multiplying by a fraction. So I'm going to multiply by a half. So do 150, then 25, then 12.5. Now, you might say that you're dividing by 2, which is true, but we always like to write it as what you're multiplying by, which is a half. Notice the 2 is on the bottom, that's why you're dividing by 2. And the reason I bring that up, that's called a common ratio, and that's what we're going to have to do in this next one. So if you look at this one, it's obviously not going down by minusing or adding a negative each time. It's dividing or multiplying. So to figure out what it is, it's definitely going to be geometric. And then to figure it out, just take any number in the sequence to figure out if it's a common ratio, and then write that on top, and then just divide by the number that comes right in front of it. And that works. So if I take this number 204.8 even, and then I divide by the number in front of it, which is 256, you'll see you get the same answer that you do here, that you get here, and it's 0.8. I've done it before on the calculator, but you can check it. This one, every time, it's actually going up by 5. So this is arithmetic. And to figure this out, this is called a common difference. That's what we say with arithmetic. You just take a number and then subtract the number that came right before it. So what came in front of negative 50? Negative 55. So minus a negative makes a plus. So you see that it is positive 5 that it's going up by each time. These questions are going to ask the same thing. This is going up by 3. You can probably see that. This is arithmetic. goes up by 3. What's the common difference? I'm just going to write 3. Could do 12 minus 9 and get it. Recursive rule, start with the first term, which is 9, and then you say what's happening. So to get the next number, take the number right before it. That's an minus 1. These are subscripts, like small and like down. And then we just add 3 to everything. Now to write the explicit rule when it's arithmetic, this is for arithmetic, you say an equals the first number, which is 9, plus what it goes up by, which is 3, times n minus 1. To figure out the 12th term, all you have to do is replace n with the number 12. So I'm going to say, all right, to get the 12th number in the pattern, it's 9 plus 3 times 12 minus 1. And if you do that in a calculator, 3 times 11, this should be 42. So that'll be the 12th number. Now, S of 10 means add up the first 12 or 10 numbers in the pattern. So it's like 9 plus 12 plus 15 plus until you get to the 10th number. Cheap way to do it is use your sigma notation. The S is saying sum or add them up. So I know I want the first number through the 10th number. And then what I do is I just take the arithmetic, the explicit arithmetic rule, and I stick it in here with the n in it. And then if I want to figure out this answer, I'm just going to stick it in Desmos. So here I go to Desmos. Oops. And I got summation, which I can find here. There it is. N equals 1 all the way to 10. And parentheses 9 plus 3, parentheses n minus 1. I get 225. Or if you wanted to, which would be the hard way, you'd have to do 9 plus 12 plus 15 plus 18 plus, and you'd have to do this for 10 numbers and keep going. I'd much rather just type it in like this as a shortcut, and it gives me what that answer would be. Express the infinite series. Well, I already wrote it in sigma notation above. I'm just saying start with the first number and go on forever. And then you just copy this down. And that's it. Now, I like to put parentheses around it when I type it in the calculator. They didn't ask for an answer. They just want the equation. You can't get an answer. It'll be, the answer would be infinity. It goes on, it'd grow forever. It would never stop. You don't need that. Okay, this one's geometric. You'd say it's dividing by 2, but it's really multiplying by a half, is another way of saying it. So I'd say, it multiplies by 1/2. That's a common ratio. So R equals 1/2. That's what you're multiplying by. I don't say divide by 2. A recursive rule, you have to say, well, what's the first number? That's 44 in the pattern. And then to get the next number, take the number right before it, and then multiply it by 1/2. Write the explicit rule. Explicit rule for here is different with geometric. You say to get a number, take the first number, which is 44, times what you're multiplying by, raised to the n minus 1 power. To find A8, I just plug it in for n. So I write A8 equals 44 times 1/2 raised to the 8 minus 1. And the calculator is going to do this for me. So I go into the calculator and I type 44 times 1/2 and raised, and then I want to put this in parentheses and then just put 8 minus 1. And you get 0.34375. I don't even care because the calculator did it. That's good enough for me. S of 10, still going to use that summation, n equals 1, all the way up to the 10th number. And then I'm just going to take my explicit rule and I'm going to stick it right in here. And write it with an n in it when I do it for the rule, because the calculator, it gives it instructions. It's like, hey, plug in 1 for n, plug in 2 for n, plug in 3 for n, add them all up to get this answer. Definitely using Desmos. Here I go. I had 44 times 1/2 raised to the n minus 1. And then I have to tell it that I wanted to go from up to the 10th number, starting with the first number. I get 87.914. Now it says express the infinite series using sigma notation. Well, it just means, hey, keep going forever. And it says find the sum of the infinite series. So for infinite, your formula is this. I might want to write that down for the note sheet. So it's going to be 44 divided by 1 minus 0.5 or 1/2, and you should get 88 is your answer. All right. So these two problems right here, I'm going to skip because they are not on the final. So you don't have to worry about those. So we're going to go down to number 10. 22 rows of seats in a high school auditorium. There's 17 in the front row. Each of the other rows has 2 more in front of it. List the first 6 terms. So it starts out with 17 seats in row 1. Then there's 19, 21, 23, 25. So this is the first row, the second row, the third row, the fourth row, fifth row. And it says to do it for 6, I gotta do one more. So this would be 27. Write the recursive formula. Well, I can definitely tell that this one's arithmetic. It's just going up by 2. So I'd say A1 equals 17. And then to get the next number, take the number right in front of it, and then add 2. Write the explicit formula. It's arithmetic. So I say, all right, 17 plus 2 times n minus 1. The rows are identified with letters to figure out what it is. The front row is row A, the second row would be row B. How many seats are there in row M? So I have to kind of think. I'm counting on my hands. A, B, C, D, E, F, G, H, I, J, K, L, M. So I think it's 14. So if M is the 14th number, I'm looking for A14. All right, A, B, C, D, E, F, G, H, I, J, K, L, M. Whoops, sorry, M is 13. So I put in here 17 plus 2 times 13 minus 1. So 17 plus 2 times 12. 24 plus 17 should be 41 seats. How many seats are in the back row? Well, it says there was a total of 22 rows from up here. So the back row will be A22. So it'll be 17 plus 2 times 21, which is 42. So this should be 59 seats. How many seats are in the whole auditorium? Now I'm going to use sigma notation. So starting with row 1 up to the 22nd row. And then I'm going to stick in 17 plus 2 times n minus 1. Stick that in Desmos. and get my answer. And I get 858 in the whole auditorium. How many seats are in there in rows 3 to 6? Well, I'm just going to copy this, except start with row 3 and then only go up to row 6. But everything else is going to be the same. So I'll go back to the calculator and then just change that 1. I'm going to change that to a 3. And then change the 22 to a 6. And I get 100. Oops, that's not right, because this is going to be 2 times n minus 1. Sorry, 96. Put that in parentheses. So there's 96. Boom. And then I don't have to sit around and do everything by hand. So hopefully this helps. Using the calculator on these types of problems are definitely going to help for sure. Good luck.